Hello YouTube, and I'm back with another video. Today we're going to go over DNS and how it works. This is probably the biggest topic that I've talked about on my channel yet. So with that said, let's waste no time and get straight into the topic. So what exactly is a DNS server? Well, in the most basic sense, DNS, or Domain Name Service, is used for translating IP addresses into names. For example, if I did an NS lookup of www.google.com, it would show me an IP address of 172.217.1.228. Now, I'm sure Google has a dynamic IP address, so I'm sure it's changing all the time, but you get the idea. But normally we don't just type in 172.217.blah blah blah to get to google.com. We normally just type in google.com. So that's basically what DNS is. It translates IP addresses into names for our convenience as humans. It's a form of abstraction. So to try to understand this further, let's look at the DNS hierarchy. So if a computer can't find the IP address associated with a host name, then it will send a request to the resolver server. If, let's say you had a computer, right? We all have computers. You probably have one right now if you're watching this. If you're on a computer and you're trying to go to a website, the computer's going to try to take the IP address from the host name, google.com. It's going to try to take that and get the IP address. But if the computer can't find the IP address associated with the host name, then it will send a request to the resolver server. And if the resolver server can't find it, then it's going to send a request out to the root server. Now the root server is the top level hierarchy of the DNS server hierarchy. So, it doesn't exactly know where the IP address is for the host name, but it will send a request back to the resolver to the top level domain server, or TLD. Basically, the TLD server contains all of the .com, .org, .net information for the server. And with this information, the resolver sends another request to the TLD server to try to find the IP address. The TLD server sends a request back to the resolver, and the resolver sends out one last query to the authoritative name server. And it sends a request back to the resolver, and with that, the resolver sends the IP address information over to your client computer. Now this may seem very complicated, but most of us don't have to deal with this sort of thing on a daily basis. Our computer and our network deal with it for us. And when you visit a website, it would be complete madness if a computer had to do this every single time you visited google.com. So to speed up the network from it having to do this every single time you visit a website that you've already visited before, the resolver creates a cached log to remember the host name information for the next time you visit the website, and it's stored in a file called the host file, but we'll get to that in a minute. Now there's different types of DNS domains, such as the root domain, the subdomain, the subfolder, the top level domain, and the mid-level domain. So take for example yahoo.com. Yahoo would be the mid-level domain because it's just the name of the domain, while .com is the top-level domain. It's the company's responsibility for assigning the mid-level domain, and it's not the computer's responsibility. So gmail.com would be considered a domain, while mail.google.com would be considered a subdomain of gmail.com. A subdomain has the same type of relationship with a domain as does a subfolder within a folder in a file system, such as NTFS. If we went to a website called pentesttools.com, we can type in a website such as microsoft.com, and we will see the subdomains within the website. And also, if you're wondering, this website is safe. It uses a 128-bit SSL encryption, so it may look shady, but it's not. So if we typed out www.google.com and put a dot after it, we would still get www.google.com. But what is this dot? This is what the root domain is. It's the highest hierarchical level of the internet, even above top-level domains such as .com or .net. The root domain is also known as the primary DNS zone. When you register a website name or a domain name, you are registering a root domain. The DNS root zone is operated by 13 logical servers run by organizations such as the U.S. Army Research Labs and even NASA. And there's another domain in DNS known as the Fully Qualified Domain Name, or the FQDN. This is the full and absolute address of a host name. So take, for example, www.4chan.org. 4chan by itself is just 4chan.org, but with the www, it's an FQDN because it shows the full and absolute address of a web page. The FQDN is mapped to an IP address with the help of a host file, which is a text file that's used on computers to translate host names to IP addresses. Without it, DNS would not work properly. DNS requests are split up from the primary and secondary DNS zones. A primary zone is the root domain like we discussed, while the secondary zone is a more or less a way to maintain a copy of the primary DNS server's DNS records. There's many other topics we could cover about DNS zones, but that would take way more time than we have. Now, with all that said, we still need to talk about DNS records. So when a computer stores information about the IP address and host name from the DNS server or website you visited, it creates a DNS record. Now there are many types of DNS records, but we will only go over a few today. So there's A records. This record type is basically, it's the simplest of them all because it's usually the default record type most people use when creating a domain on a DNS server. It's used to direct users to a domain or a subdomain, then to an IPv4 address so they can access the server. Now there's AAAA records, which is basically the same thing as an A record. This time, instead of directing a user to a domain with an IPv4 address, it directs them to a domain with an IPv6 address. So now there's CERT records. These records are used to store site certificates such as SSL and TLS for security and encryption. And that's basically it. Now there's MX records, and MX stands for Mail Exchange. And that's most likely why Microsoft named their software Exchange Server. So as you can tell, this record is primarily used for sending and receiving email, also known as the SMTP protocol, and it specifies which servers to deliver mail to. That's why when you're sending an email to someone, you need to type in their email address, usually followed by an @ like @example.com. This record translates that email address into a functional IP address so you can send out the email and stuff like that. Like I said, there's many records out there, such as NS, alias, CNAME records, NAPTR, PTR, and text. But we just went over a few of them today, as this is just an introduction to DNS, and also for time convenience sake. And with that said, there's also commands to control DNS. You can use ipconfig/flushdns to try to flush out corrupted cached results in order to resolve the host name properly, because in a DNS server there could be some corruption sometimes. It's bound to happen. No computer is perfect, but if you want to start fresh and flush your DNS, you can do it using this command. And like I said earlier, you can use NSLOOKUP to try to find the IP address associated with the host name. That's all NSLOOKUP does. So with that said, that's just about what DNS is. That just about covers it. In the future subsequent videos, we will go over DNS spoofing and how that can be used to deceive the network into diverting traffic from the legitimate DNS server to the attacker server, as well as talking about how to set a DNS server up on a Windows Server 2019 machine. If you all enjoy my videos and like to see more of this content, make sure to like and subscribe. It really helps and I would greatly appreciate it. I'll see you all in the next video. later.